Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, graphing trig functions. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 4 parts, so leave a like, smash subscribe, and let's get started! Now, there's 3 main things you're going to need in order to graph your trig functions. However, if you're new to trig functions and you haven't seen my earlier videos on trig functions, I recommend you pause this video now and check out my earlier videos. You can find them right up here. That'll give you everything you're going to need to know at this point in time for this video to make sense. So check that out and then come back here once you have a good understanding. But of your 3 things that you're going to need in order to graph your trig functions, the very first thing you're going to need is an abbreviated unit circle. Now, what do I mean by an abbreviated unit circle? Well, I mean you don't need to fill in everything in order to use it. You're only going to need 4 values. These 4 values that you see here: 1, 0, 0, 1, -1, 0, and 0, -1. And of course, you know that these values are going to correspond with the radians 0, pi over 2, pi, and 3 pi over 2. And of course, 0 and 2 pi are going to have the same value here. And regarding a unit circle, you're still going to need to know which trig functions correspond to which portion of your value. We talked about this in an earlier video. However, here's a shortcut for you. X comes before Y in your alphabet, and X comes before Y in your point. Well, if we take that same logic, C comes before S in your alphabet. Therefore, C is going to come before S in your point. That lets us know that the very first portion of this value is going to be our cosine function value, and our second is going to be our sine function value. So in actuality, you can make an abbreviated unit circle for just cosine and for just sine if you just remove the value that's not necessary. So if we wanted to do one just for cosine, we can erase all the second portion of the value, and you're left with a unit circle with the values pertaining just to cosine. And of course, you can do the same thing for sine. And you may actually want to do something like this in order for you not to get confused when you're making your graph. Which leads us into our second thing that you're going to need, and that's the actual graph. But unlike your typical graph, which has an x-axis and a y-axis, you're going to have a radian axis, or degrees if you want to do degrees, but typically it's done in radians. You're going to have a radian axis, and you're going to have a value axis. And the values here are going to correspond to the values in your unit circle. And for your unit circle, the maximum value is going to be 1, and your minimum value is going to be -1. This is going to be true for both your sine and your cosine functions. However, tangents are going to be a little bit different, and you'll see what I mean when we get to that at a later point in the video. And if you're trying to fill in your radians, remember, for your unit circle, you start at 0 and you go all the way to 2 pi. You're going to do the same thing here. And that's all you're really going to need for this graph because of our third thing that you're going to need. And that's to know that all your trig functions are going to repeat themselves. And your cosine and sine will repeat themselves with each full rotation from 0 to 2 pi. So if you want to find out more of this graph, whether how it looks beyond 2 pi at 4 pi even, or if you want to find it previous to this right here, so let's say -2 pi to 0, all you have to do is repeat the graph. So if you can graph it from 0 to 2 pi, you can repeat the graph for every 2 pi, because as you go around this unit circle, you're not going to be hitting any new values for every new rotation. It's going to be the same values, so it's going to be the same graph as you're going beyond 2 pi or previous to 0. Now, tangent, once again, is going to look a little bit different here, but you'll see what I'm talking about. It does repeat, but it doesn't necessarily repeat on this 0 to 2 pi scale that you see for cosine and sine. But like I said, we'll see that at a later part of this video. Now let's take everything that we just talked about and graph our cosine function. So here we're going to be graphing our cosine function, and we have our graph and we have our abbreviated unit circle. But notice I made sure our abbreviated unit circle only had the values that corresponded with our cosine function. So all we're going to do is graph these points and then connect all the dots. So at 0, remember that's 0 here, our radian axis. At 0 for our radians, we're going to be at 1, so we can put that here. At pi over 2, we're going to be at 0, so that's going to be here. At pi, we're going to be at -1, so we're going to be down here. At 3 pi over 2, we're going to be at 0, so we're going to go back up here. And at 2 pi, we're going to be at 1, so we're going to go back up here. Now we just connect all the dots. So we're going to start here, go down, go up. So this is going to be how you're going to graph your cosine function, from 0 to 2 pi at least. If you want to see how it looks before 0 or after 2 pi, just repeat this graph. And you see that this was enough to graph it, which confirms that you didn't need much more for your unit circle. Keeping it simple is going to make it easy for you to remember. But now that we've graphed cosine, let's graph our sine function next. Now we're trying to graph our sine function, and we see we have a different abbreviated unit circle here. We have the one corresponding to these sine values, 0, 1, 0, -1. And of course we have the same exact graph here. So we're going to plot this in the same fashion and then connect our dots. So at 0, this is going to be 0. Our value for sine is 0. At pi over 2, our value for sine is going to be 1. So we're going to put it up here. At pi, our value for sine is going to be back to 0. So we're here. At 3 pi over 2, we're going down to -1. And back at 2 pi, we're seeing we're at 0. So we're going to connect all these dots, and we see we have something like that. And once again, you can continue this. You can repeat the same graph beyond 2 pi and before 0. I recommend you do that and check it out and tell me what it looks like in the comment box below. But this is how you're going to graph your sine function from 0 to 2 pi. Now let's jump into our tangent, which is going to look a little bit different, but we're still going to do the same type of work here. When you're trying to graph the tangent function, you need to know that your tangent function is going to be sine over cosine. That's very important because you got to take the value for sine at your radian and divide it by the value for cosine at that same radian. Therefore, our abbreviated unit circle is going to need to know what both cosine and sine values are going to be. And you notice that our graph looks a little different here too, because we're not going to be repeating on that same scale. We're going to need to look at this, and you'll see exactly why in just a second. So let's look at where we are at 0. So right here, what is the tangent value when we're at the radian value of 0? Well, sine over cosine is going to be 0 over 1. And what's 0 over 1? 0. So we know we're going to be right here. How about when we're at pi over 2? What is the tangent value when you're at pi over 2? Well, we have sine 1, cosine 0. What's 1 over 0? Well, that's undefined. So we have an asymptote here, right? So you have to draw your asymptote. So since we didn't have an actual value here, let's look at the other value I put here. Well, we know that going from 0 back this way is going to give us a negative pi over 2. So what is our tangent of this negative pi over 2? Well, it's going to be -1, 0. What is that going to be? Undefined as well. So we have another asymptote here. So we have 0 and we have 2 asymptotes. But how does tangent look in between? We don't have any extra values here. So how do we know what it looks like in between these asymptotes? Well, take a look at your abbreviated unit circle. When you're going from 0 to 2 pi, notice that your cosine value goes from 1 to 0. That means it's blowing up, right? Your denominator is getting smaller. Therefore, your overall value is blowing up in magnitude. However, we notice that our numerator is going from 0 to 1. We're going positive. So we know we're getting more and more positive as we're approaching this asymptote. So we can go like this. Let's do the same thing as we're approaching negative pi over 2. Well, notice that our denominator, our cosine, is going from 1 to 0, hence our asymptote. So it's getting larger in magnitude. However, our numerator now goes from 0 to negative 1. We're getting more and more negative now. So it's getting bigger magnitude-wise, but we're getting a bigger negative number. So we're going to look something like this. And of course, you never actually hit your asymptotes, so this is how your tangent function is going to look between negative pi and pi over 2. So I hope you were able to follow along with today's video, and I hope you now know how you can graph your trig functions. However, if you have any questions about what you saw today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. That's all the time I have for today. I'm really hoping to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.